Good evening. I'm in my limits. I can't move. I can't move either. Both kind of my, style. So I know low on drinks, so hold on your energy for 2 more hours and we'll be good. My name is Sheen Brisals, and I've been in the industry, as you can see, for many, many years. And over the last 10 years or so, my focus is mostly on cloud and serverless adoption. And that's because my previous company, where I spent more than 8 years, I was one of the main guys, made them move to AWS and also adopt serverless. So that brought me into speaking and writing about technology. So that's how the serverless book came out last year. And it's basically about, how can you adopt serverless in your organization. I'll take you through all the development cycle, like developing architecture, patterns, and testing, operation, even sustainability. And it's not something that you would use to write Lambda functions or anything. It's more of a, sort of the best practices book. And 11 chapters. Each chapter has an expert from the industry, from Danilo Porkshop, many of you know, to Adrian Cockcroft and many others. And the speaking book is basically, so my experience of speaking at conferences, bringing a different life cycle, like a speaker life cycle into, you have ideas, you have the passion to speak, but how can you kind of develop, and how can you submit the proposals and find conferences, and how can you stand here and deliver the talk and handle the audience questions, so on and so forth. Yeah, so if you're interested, that has a, sort of good resource. It's a 300 pages long book. So my initial agenda was a long one. I probably will cut down 1 or 2 due to time constraints. So this talk is about Amazon EventBridge, and if you're someone new, this will be beneficial for you. And looking at some of the patterns, mostly the event-driven patterns that you can do with, with EventBridge and many other AWS managed services in the mix. Right, so for many decades, most of us didn't really understand what resiliency was, right? And then within a single day, the entire world learned about resiliency, thanks to AWS. And many started preaching others as well. So that's interesting, because that awareness has reached far beyond. So that is basically the impact that we have in the industry as engineers or as providers of applications and stuff. But someone said it many years ago, right? Things will fail all the time. But no one listened. But people just say what Werner said and stop here. But he says something beyond this. He said, to cope with that, you need to apply all the best practices and build systems that, stand up, fault tolerant, all sorts of things. But they didn't listen. A few years ago, he also said this thing at a reInvent keynote. The world is asynchronous. Everything is event-driven. And there was a nice video clip he showed, and it was so nice. Now, if you think of most of the modern applications, the 2 most important concepts, asynchrony and event-driven. Now, if you know this, you think that, oh, that's Sheen, I know all these things, you just move on. But I worked with engineers, still work with engineers who come from traditional engineering practices or spending time with other technologies. They find it so hard to kind of understand this. So it's important to just to go through what exactly this is. Say, for example, you have 2 services. Say you are looking for the price of an item. It makes a synchronous call, and you are waiting there to get the price back, because if there is a delay, it's a problem. Now, if you take sort of a business application, let's say service D is payment service, and service C is like shipping or order fulfillment. What they do is, usually when they ship the order, they invoke a call to capture the fund. That's when the money transfers from your bank to the retailer. So what they usually do is, they usually send in a bulk of hundreds or thousands, depending on the business. So in here, a batch job gets submitted, and then C can't hang around there because it's a long processing job. What does it do? So for that, we have this typical CQRS pattern, right? So we post the job status somewhere, then we open up another API to pull. So this is what typically services do and engineers implement. Now C has 3 problems. Can anyone name a problem? What C faces now? So number 1, how soon after submitting a job it should start polling? How often should it poll? Right? 1 second, 2 seconds, 3. And then how long should it poll? When should it stop? Is there a stop? Okay. So that's kind of the difficulty applications and teams get into. Let's twist it around. So the same 2 applications or services, it sends back an acknowledgement. What then service D does is it sends back an event as it processes the payments. So this is like getting into the event-driven territory because C is not waiting there; it just reacts to the event as the event comes into. So similarly, you can see that we use different channels like message queues and the event channels and buses and things like that to do this. So basically, this is kind of roughly 1 page of event-driven architecture and how why we are doing it. So event-driven architecture basically exactly is like applications kind of driven asynchronously invoked by events. Now there are 4 main things if you look at event-driven architecture. So there is a producer, that application that pushes events onto a broker or a channel or a carrier or a bus, whatever we call it. And then there are consumers who consume the events as they like or as they need. And there is also the core of event-driven architecture, the events that flow around. Now each one is different, has responsibilities. So if you look at so a producer or a publisher, it has a bunch of sort of responsibilities. I mean, we say that it should be agnostic of consumers and stuff, but the reality is, in a small organization or in a small team, you sit next to your consumer team, which is your friend's team, then obviously you're going to talk about, this event is going to come with these things, which is good because we need collaboration. The thing that we need to be mindful of that, don't twist it purely or specifically for that particular consumer. Just think that is it open or is it kind of agnostic, and schema and a bunch of things that we will see later. And similarly, when it comes to the event consumption, consumers have also responsibilities. For example, there is no guarantee that the consumers will get the event only once. It may be kind of duplicate events will come through. So they need to build the idempotency and how to take care of ordering if the producer or if the delivering bus or channel is not kind of delivered in that particular order. So these are the challenges for the consumers. And often consumers do is like as the consumer application receives the event, it often stores somewhere before it processing the event. So there is a pattern called storage first pattern named by Eric Johnson. So there are things that possible with the consumers. And then the broker is kind of the the channel that takes this from one end to the other and does a bunch of things in terms of transformation or filtering, and it decides you can configure rules to say that okay, this event with this attribute or this something that should go to this consumer or that consumer. So those sort of the flexible ways of delivering the events. And when it comes to EventBridge, why do we need EventBridge? So EventBridge was released back in 2019 if you are completely new to this service, and since then its adoption has kind of gone up and up, and because that was a missing service at that time at AWS. And the reason why we need EventBridge is because often what teams do is that when they start serverless adoption, they start with sort of the experimentation mind, right? So they start something simple. Then they keep adding new services and all these sort of interactions and connections and things one after the other. They just get added on and on without giving much of a thinking about best practices or anything. So all of a sudden you get into this sort of a tangled mess of serverless application. So this is one area where you can think of EventBridge. But often what teams do is they think, oh, now we need microservices. That's the problem that, will solve this one. So they put microservice and, in a hurry, they push all the services into some of the microservice boxes. And then they think that, oh, we solved the problem because all microservices. But the problem is those tangled interactions are still there to be solved. So this is where we can bring EventBridge into kind of to calm down the interactions and act as the mediator or the channel for these microservices to kind of communicate in a more sensible way. And this is what sort of drives the EventBridge adoption mainly because of the ability for various applications and services to come together. Now you can do it between sort of accounts as well, cross-account interactions and so on and so forth are all possible. So EventBridge is basically an event bus. This is a struggle with tight hand. So it's basically the event bus that takes data from one to the other. Now, if you're not familiar with EventBridge, basically EventBridge is so event buses. And you have custom event buses and partner event bus, and also AWS runs its own event bus for all the AWS events. So on one side you have the producers, and producers push events onto the bus, and on the other side bunch of consumers, and before the event gets to the consumer you can have what we call the routing rules, or the logic how you want to push those events out to those sort of consuming applications, either within that same account or into different multiple accounts. So this is kind of basically the sort of the EventBridge thing. So now comes to the most important aspect, which is the events. So this is an area again many teams overlook because of just get started and do something with events. So that's why I always insist that spend time in designing your events, or at least agreeing a scheme or a structure, or at the overall high-level structure of how you want to, sort of the structure of the events or write the events. So events, as you probably know, it's something that happened in the system. That is the kind of the puristic way of thinking as an event, but there are different variations as I will, talk soon. And so the event structure, if you are familiar with EventBridge, so this is like the EventBridge, sort of the standard structure. So these are the standard attributes, and then the detail section is a place where you can dump your sort of JSON payload. And this is where teams make a mistake that one team will come up with the JSON structure of their own, they will add and send. Another team will come with a different structure and they will put in there. When this, sort of the events get to the event bus and flow around, somebody is trying to, set up the configuration rules or filtering conditions, they struggle because there is no uniformity. So this is where you need to kind of think of bringing some kind of a structure. So when EventBridge was launched, when I started working with, I proposed this sort of a simple separation of the data. Like you have a metadata section and you have a data section. So this allows you to at least provide some separation when you think of publishing events. For example, in the metadata section, you can put all the the whereabouts of the event. Where is it coming from? Which domain? Which service? And also the name and tracing ID and things like that. And many companies have taken this concept and they adapt it to their own purpose. For example, if it's a business critical event, say something related to an order, and if the business logic says that order should be persisted for 100 days because that's the 90 days is your refund limit, so you should be able to pull this back. You can send in as a TTL value. So the downstream consumers will acknowledge, or they will kind of comply to that. And also you can add your own sections, and tracing ID, you can make a decision in your organization or team that it should be kind of passed on to every kind of consumer or wherever it goes. Makes the distributed tracing a lot easier. And when it comes to the data section, this is basically the instant data, and how much data you put here is up to you, but always just keep the data as minimum as possible. There are other patterns like claim check and so on and so forth. If someone wants more data, they can then call back an API or something from the producer to get the data under sort of secured ways. So this is something important, and if you are working in a team with EventBridge, I would highly recommend that having some sort of pattern and following it across your teams and organization. So I mentioned about sort of the event categories and types. So this is all kind of my way of sort of saying it doesn't need to be like this. So for example, domain events is common across several organizations. Will have the domain events. These are the kind of the gold events that fly across between the different domains. Operational events are like I consider them as like status reports or some system downtime error reporting and things like that. Though those errors mostly stay inside your own domain or inside your own bounded context. So that way you can think of, and then if you're working in AWS, you have to deal with the AWS events as well. Now, event type is specifically about a particular event. What does it do? Does it carry data, or is it a command going out, or is it querying something? So this is why I said, though puristically we say that event is something that happened in the past, there are different interpretations of how teams make use of that concept for their purpose. And so this is again something up to you or up to your organization to come up with. This is all about clarity. And that means when you set up a filter condition to consume an event to a particular a target or a consumer, you can decide on, okay, I need, if the event, if it's a query, I'm interested, or it's a command or something like that. So you can use that way to make it more manageable and reduce complexity. Now, so let's move on to patterns, a few patterns I want to talk about. So when it comes to sort of the patterns, I like this the quote I used many times, because if you think of patterns, we are basically kind of using several patterns. If you go back, the Gang of Four patterns, right? So that came out, so became popular. And then Gregor Hope and others wrote a book on patterns, which I think is more than 10 years old, I think. So if you look at those books, you will see, say, API gateway as a pattern, or queue as a pattern, DLQ as a pattern. But nowadays, we use them everywhere because they are all part of the bigger patterns we use. So even in your team, you may be coming up with a new pattern for your working use case. That can have a name. So even in my book, I introduced a couple of patterns that I came up, or our team came up when I was working in my previous company. So this is the way to think of patterns. It's not like there is one strict pattern that you need to use. There can be different way, implementation variants of a particular pattern as well. Let's start with choreography. How many of you are familiar with choreography pattern? Okay, that's encouraging. So so choreography is basically the name from the dance. So what happens is, in a choreographing situation, according to the music, we dance, right? We don't need anybody instructing us, you do that step or you do this step. No, we listen to the music and we just do our actions. Exactly this is what happens in choreographic or coordinated microservices. Because if you think of microservices, they are sort of services or applications, they listen to events. When they consume the event, they know exactly what to do. There is no need to tell, because they know what to do in that particular state. So for example, here is a simple application you can think of. So you bought a product, you are registering. It goes through a bunch of steps, like you get loyalty point, you get a discount for the next purchase, or also your product gets registered in your manufacturer, you get warranty, etc., etc. But thing is, if you look at this flow, you can easily identify there are dependencies between, because you need to generate an account before you can email the customer. And also there are certain things that can go in parallel, so they can happen in parallel. So these are the ways you need to kind of think when you analyze your problem, when you build sort of serverless or event-driven architecture. So these sort of questions will, make engineers move towards architects and come up with, better solutions. So what you can do now is like, so you have, sort of the microservices, or it could be, any application. So product registration goes here. What it does, it emits an event onto the bus. So that's a product registered. And what happens, maybe there are 2 or 3 services, they are all interested in this particular event, so that they can then now start their work and, on their own. Nobody needs to tell. So, and then, they also kind of publish other events, and that goes to different service. And for example, there is a manufacturer that, gets registered, you get the warranty or whatever. You can have a different rule to, reach the manufacturer. So in EventBridge, there is a service called, there's a feature called API destination. So that will allow you to, reach an external HTTP endpoint without adding any code of your own, or without having a function in most cases. So these are the possibilities that are, we can do with, EventBridge. And some of the key points to, remember when you do choreography, think of as a, coordination, service coordination. And there are things like, the idempotency and things I talked about earlier on. So those things to be, taken care by the consumers, but that's all part of, the implementation. Right, okay, so I'm not going to talk about the pattern, but I just wanted to, mention this because we've been talking about this for ages in the industry. Like everyone says, the more code you write, you're liable, etc., etc. And is it still true with all the AI agents and stuff we have? Because it generates code left and right, center, all the code, right? So who is going to be liable? Is AI going to be liable, all the AI code it generates? I remember, if you know Venkat Subramanian, is a great talker, speaker and technician. He used to say before the AI world, and whenever the IDs used to pump out or spit out code, the templates, he used to call it a code vomit. So that's exactly what happens now with all the AI bots and stuff. So anyway, the bottom line is, I'm not going to go to the pattern because of the time constraint, is write few functions. So think before you engage or come up with a function. Don't just come up with a function without a reason. Now, I often call as a lambda hammer in the past, because when you have a lambda function or a function as a service, every problem will look like, oh, I need a lambda there, I need a lambda there. So just pause and think before you, writing a function. So this is basically the functionless. I last night I went through my kind of speaking log, and because I spoke at AWS user group long ago, and it was 6 years ago in 2019 November, I talked about functionless as a separate talk. So Ijaz, Paul, those guys were there. I think it was at the, I don't know if that still building is with Moonpig or not, but that building, yes. Yeah, anyway, so think of that before you, because in AWS, if you're familiar with AWS, API Gateway, you can integrate with so many services without having to put a function in between. Similarly, step function allows you to, target so many services without having to write a single piece of code. So have a think and you kind of, develop your serverless applications. So I don't need to talk about this thing. Everyone knows this, right? Now, there is a pattern that that often helps in these sort of situations. So what can go wrong? In our recent case, probably the entire region goes down. So who knows what is going to happen? So all these things can happen all the time. So this is why we need to kind of incorporate at least think. If you're starting new with serverless development, at least have that thinking and raise the question so that others will slowly kind of understand and then bring all the things. So the circuit breaker pattern is something unique and something widely used, so common. And if you are not familiar with the pattern, I'll give you a quick overview of what it is. So basically, this application is the app is calling an API. API calls a function. Function goes to the third party. Okay, simple flow. Now, what will happen is, so in this situation, the circuit is closed because the function can reach the target and come back. And in a circuit open situation, and so in this case the response comes back, it's a synchronous call, that's all good. And what happens is, if for some reason network issue or a third party down, the circuit you can't reach. So this is the situation that this particular pattern tries to deal with in simple terms. So this is a circuit open situation. So this is kind of situation that you want to avoid, because it can cause chaos if not dealt properly depending on the use case. Now think of a high volume situation, the app's calling every a few times every second. So what kind of chaos it can cause. Now, as I mentioned, the circuit breaker pattern is basically managing the situation. You have some logic to identify when the circuit is open or closed, and then react accordingly and deal with the situation. So for example, so this is like what I mentioned. What often the implementations do is, so before when the function invokes the third party or interacts with third party, it stores the status, is it good or bad in a table, and then it may have a logic that you declare it bad if it's like 3 tries or 5 tries or whatever, and then it kind of keeps that count, so that before the function calls the third party, it will check the status whether to see, oh, can I call, or should I do something else. So this is like the sort of the simple situation where you can implement a circuit breaker. Now the problem is, this is fine if it's just a single function invoking the third party. What happens if it's a critical third party application, bunch of your teams and services or applications call the same thing? Would they kind of go and do the implementation on same implementation? Probably not. So this is where you probably will think of projecting this as a service on its own. So this is kind of a different implementation. This is taking one step further. So now we have a use case where a bunch of applications call the third party. So you need a common way of declaring the status of that particular application, or the sort of the network or the communication. So what you do is you store in a table, say it's a DynamoDB table, and there's a Lambda function that manages things. It has the logic, okay, when should I declare it as a open circuit, after 3 tries or 5 tries, and how do I kind of close the circuit based on the data it receives. And then what you can do is, now it has the option, it allows the option. So it can now store something in the parameter store, so that applications can quickly kind of fetch the value and check before calling the third party, for example. Or it can push an event onto the bus. Say, remember I mentioned about the operational events. So this can be an operational type of event where a bunch of applications can consume, and then they decide whether to kind of, or you can open up an API endpoint that will kind of the applications can call to check the status. So there are different options. Now this is like a bit more like established setup, where it makes it helps in multiple ways to consumers to kind of deal with the situation. And so one of the main things with circuit breaker is to fail fast, because for various reasons. So if the connection takes a long time, if you're using a Lambda function, obviously it's going to cost you money, and also you're holding the app or the user or consumer back. So this is why, if something you can't do, you need to fail fast quickly, so that the the calling application or clients can take different actions. So this is like common, many teams do, and it's kind of highly recommended way of dealing with unstable systems or third-party applications. So you can basically build from here on different things. So now you may be asking, you may be wondering, what will happen to those kind of requests coming in? How do I handle? So this is kind of the next part of circuit breaker. So this is where you would think of some way of storing the failed request and then replaying them when the connection is back to normal, or when it's connection is closed. So there are different ways. I'm not going to go through the details. I often say something about the EventBridge archive and replay. So if you think of SQS, what it allows is you can buffer all the failed requests. Then you have different logic to kind of read back and then submit those requests back. Similarly, you can use DynamoDB. But one thing you need to be careful if you're using DynamoDB is if it's a high volume situation, then you get, tens of thousands of failed requests, then you need to think of how am I going to query those, the table to replay, because you have DynamoDB has its limits. And EventBridge itself provides the archive and replay mechanism. And that way you can, basically archive is like a different queue within the EventBridge. So you have a separate rule, and that those events will be pushed into the archive buffer, and then from there you can replay. I mean, there are constraints, but if you are interested, then this blog post I wrote a few years ago has all the details how to implement properly. I think there are two parts to this blog. Right. So the next one is orchestration. This is kind of it often paired with the choreography I mentioned earlier on. So similar to choreography, this also originates from orchestra, because here there is a controller who will basically direct what to play, and the conductors and how they kind of instruct. So when you think of AWS orchestration, it's step functions, right? So that is the main orchestrator of AWS side of things. So there are different ways you can use orchestration. Not many people think that way. They just implement a step function and let it do whatever it like, and so have a think. So I propose three different styles of orchestration. First one is the simplest one, in-service orchestration. That I will show you. That happens everything within a particular microservice. There's nothing going beyond. And the other two are a little more reaching out to other services. So for example, the in-service, so you have a microservice and you have your step function within the microservice. So no interactions except for the trigger via its API or event trigger or whatever, all happens within the microservices. So nice and clean, simple. You don't need to worry about other dependencies and things. So this is simple. And if you take it to the next level, that is the cross service. So another thing is like step functions has two flavors, standard and express. So in this case, it's mostly it's good for express case, because this request comes in, you do a bunch of things, and it goes back. Express state machine can act as a request in the request response pattern as well. Okay, so the cross service, same, but it can reach out to other services or other applications via APIs. No other kind of a communication, not directly reaching out to a function or a queue in a different service or a different account. It all happens via proper contract communication channel like APIs, for example. And so this has its own kind of use case, situations where there are a bunch of microservices in your own bounded context, for example. So they need to kind of coordinate in order to fulfill a business logic. So this is kind of the ideal way of orchestrating. And the third one is distributed orchestration. So you need to stick with me if you're not familiar with this. So let's say there are 3 domains and 3 services. Let's say the microservice in domain A is the main orchestrator. So for example, it deals with, I don't know, insurance claim request. So this is the one holding the overall logic, high level logic, for example. But it requires other services from other domains to fulfill. So for example, this call, this, the service B, it can take hours or days. The other one maybe takes weeks, for example, to complete. So how can it manage this sort of orchestration? So without kind of polluting its own data model, it is basically kind of delegating things to other services, delegating tasks to other services. So this is where task token comes into picture. Are you familiar with task token, anyone? Okay. So task token is basically what happens is, so task comes here, it now this service, right? So what it will do is, it will kind of emit a token, right? I'll explain. So the token goes here, and this execution will pause there. Once it's issued the token, it will pause there, because standard step function can live for a year. So that will pause there, and the token must then come back at some point, a day or two or week or whatever, and then the task will continue. So this is basically how the flow works. So for example, to give an example, so this will emit an event with a token. This event will carry a token, and that goes to the other event. So this is purely event-driven architecture and with orchestration combined. And once the microservice C completed a job, it will push an event, publish an event back with that token, the same token. And then there must be somebody who will be receiving that event and handling that event, which will be a function. And this function will submit the token in that event back to this main orchestrator, and the flow will continue. So this is kind of in effect how to do this sort of the distributed orchestration with step function and EventBridge in an event-driven architecture way, using task. This is quite powerful actually. In my previous teams, we've done quite a few implementations. I mean, huge step function flows and things work pretty well. And there are a bunch of things you can do with step function task token. So this is like the task where it will kind of put the wait for task token. So this is what will pause the execution, and then you can also assign heartbeat that will this decides how long it will wait. If you need more time, you can always increase the heartbeat. So there are other patterns and ways to do that in a sort of more complicated scenarios. And when you push the token in an event, so this step you can do from within the step function. This is basically your emitting an event. So with the metadata I showed you earlier on with the token, and is going out to a consumer. All you need is the consumers need is they need to kind of keep hold of the token, because those tokens are unique, and the step function can have multiple tokens. That means multiple parts of the step function can pause independently of the others and start the execution. It's quite powerful, and if you are new, I highly recommend that you try it out, because these things allow you to experiment different ways of building your application. Sometimes there are better ways that you can bring in to make the solutions that you build better. So if you are interested, I think it's a blog again I wrote a while ago. It has all the details about what exactly is the token, and how can you kind of bring all these things together to make your event-driven architecture work. So towards the final pattern, so bounded context, if you are familiar with the domain-driven design, you know what bounded context is. Bounded context is a small boundary within which a particular model is valid, and then you will have multiple bounded contexts. This is all coming down from domain, subdomains, and bounded context. So this is breaking down your business. So when it comes to event-driven architecture, I propose a sort of pattern just to keep things less complicated when you implement. Often people don't consider the events as APIs, because that's where I was insisting on coming with the event structure and schema, because that really helps to streamline things. So this is like a gatekeeper pattern. It can, it has different names across different organizations. So this is basically guarding your own context boundary. So what do I mean by this? So for example, we have a bunch of domains. So we have a bounded context here, so which I think is payments, for example, okay. So there are a bunch of microservices. They push out events to, they have an EventBridge event bus internally. So this is within a microservice boundary. And there are other events like, so this is again operational event, and you can have other events flowing into this particular bus. But when you need to kind of transact events with external domains or external applications, then you need to put all the logic here, because this could be kind of swarmed with thousands of different events, not necessarily all or domain events. All the rubbish goes in here. So this is where I sort of propose coming with a gatekeeper bus, so that all the external interactions this bus can handle. So if you are emitting an event to a different domain, obviously there could be a domain event. So this can have the logic. Similarly, interacting, if you are doing HTTP target or anything, everything sits in here, and this event bus, it doesn't care. So only so you have the rules and things, so that you push only the things that going out to the thing. If you are familiar with the anti-corruption layer in domain-driven design, this is kind of the anti-corruption layer implementation for the event bus, event-driven architecture. So that's basically it's doing. And so it's basically what I said, so in some organizations they call it internal bus and external bus. It's however you call, it's basically differentiating or untangling the mess, that you have a better way of dealing with external applications. And what can you all do is, so in here, if you have a microservice, you can even translate or transform the events going out to, I don't know, cloud events or async APIs, or however you want to transform. You can do all the logic here, because this, this doesn't care. It doesn't need to be, sort of peppered with everything else that you need to do. So this is basically, the sort of the gatekeeper bus I call, but, it's up to your implementation and however you want to call it. It's all about, sort of reducing the complexity of the event-driven architecture, because people often think that event-driven architecture is complex, and there's a complete separate talk on that topic as well. So that's something to think of. So I close with based on what I said. So there's a FAQ. So people often get confused. Okay, how many event buses? How do I kind of deal with? Should I have enterprise-wide bus, or every domain, or within a bounded context? It depends. You can have one or more combinations. For example, so as long as you understand what is involved with these sort of event buses. For example, if you are in an autonomous small team, so you may have a bounded context event bus. Yeah. So that event bus may publish events onto your domain bus for other teams to consume, or to an enterprise bus. If it's a small organization, you may get away with enterprise bus. You don't need multiple kind of domain buses. And if it's a big organization, you may want to structure this way differently. Or you may have, I don't know, bounded context, you will have EventBridge event buses, and enterprise may have Kafka or something else. So you have these sort of options to separate those sort of concerns and keep everything kind of in order when you do event-driven architecture. So that's all for tonight. Let's, thank you so much. Thank you so much for listening. Thank you.